this thing in light mode. Right. Okay, here it is. Alright, what subject shall we start with? Programming and data structures seems good. Let's see the previous gate questions. What is this? T represents various traverses over a binary tree. Okay. The set S represents the order of wisdom nodes during the traversal. Which one of the following is a correct match? In order is basically right. Node left. Alright. One is going to be L. There are two options. Pre-order is basically node left and right. Two is going to be M. A is going to be your answer. Pretty easy one. In a C runtime environment, which of the following is stored in heap? Uh, there are basically two things, namely the stack memory and the heap memory. Dynamically allocated array of integers created using ML function call, right? Dynamic memory is stored in heap, if I'm not wrong. So C is going to be your answer. Yes, that thing works out. Okay, something opened up. Right, it did not format properly. I don't know. I feel like I did this question already before. Yeah. Okay, leave it. Consider a stack as in a queue. Yes, we need to get our notepad here, people. Right, it's been a long time since I opened my OneNote application. So we'll be logging in until 10 o'clock. Oh, not that. Yep, this one. Okay. Now what? Yeah, it is working. That is more than enough for us right now. Applies it in general. Um, this is what it is. Yep, the great works out. Yes, yes, it does. And gate. Straws. Okay, this pen is enough for us, I guess. Nice. Yep. Stackers and a queue, both of them are initially empty, have a capacity to store 10 elements each. The elements 1 to 3 prepare one by one in the order. When an element arises, it is assigned to either S push to S or Q and Q to Q. Once all the 5 elements are stored, the output is generated in 2 steps. First, stackers is emptied by copying all the elements, and QQ is emptied by dequeuing all elements. The output of the following procedure is 4, 3, 1, 2, 5. Given the output, the object is to predict whether an element is assigned to S or Q. Element is not okay. Once all 5 elements are stored, just push them into the stack and see how the output is. Right, one is into the stack. 2 is into the queue, 3 is into the stack, 4 is into the stack again, 5 is into the queue. So first stack as is emptied, that will be 431. Okay, and then queue is emptied, that is going to be 25. Alright, is it like multiple select? It is multiple select, so A is correct, and 1 is into the queue, 2 is into the queue, 3 is into the stack, 4 is into the stack, 5 is into the queue. So first you will get 3, 4. That is where like you will get 4, 3, 1, 2, 5. Okay, that worked out. Like you pop these two and then you DQ these three. And the third one is into the queue, 2, 3 into the queue, 4 into stack, 5 into stack. That would be 5, 4. So that is obviously wrong. And 1, 2, 3, 4 and 5, that would be 3 to 1, that is also wrong as well. So A and B are the correct answers. Yes, I have did it, and there are no answers to this, which is kind of concerning. Okay, not too bad. I used to do this. I don't know what's happening right now though. Pointers. Why is there a comma? Okay, wait. It is a pointer. It is a pointer, and you got A, B, C. A with 5, B with 11, C with 20. Pointer is equal to ampersand of A. A has address of let's say 1000. A pointer holds a value 1000. Does it? Yes, it does. And you are calling by memory, so by dereferencing the pointer, you are accessing the value in 1000. That is C contains 20, that will be placed here, and pointer, the address of C is stored, let's say it is 1010. Now it contains 1010, right? A is equals to ampersand. All right, so the value in the address of 1005, let's say, is 11. Now A will be 11. C is equals to dereferencing of what is the address of pointer, that is let's say 1010. That is the wait, no, it is dereferencing 1010 contains C, that is 20, and minus A, that is 9. C, alright, it prints 9 if I'm not wrong. I've already done that before, and it indeed prints 9. Wow, cool. So there is a learning curve, and you are just not putting enough effort. Not too bad. Not too bad. Length is equals to n plus 1 minus start. Okay. If length is less than 1, or start is less than 0, or end is less than 0, return 0. If length mod 3 is equals to 0, return the recursive call of start plus 1 and end, else. Okay. The maximum possible values returned from this function is the maximum possible value that can be returned from this function is. How can you even do that? I mean, how can you even tackle this question in the first place? Okay, this is the base case, that is absolute. If length mod 3 is equals to 0, is equals to 1. Okay. Okay, let's do some like, okay, it is modulus function, so it really doesn't matter how large the input is. So it does not matter how large input is. Are we making any progress here? Yeah, the pen is alright, I guess. So let's do it like case with 3, 4, and 5, right? Let's do that. Length mod 3 is equals to 0. It is returning function of okay. Okay, wait. But start comma end, right? Let's do 3 comma 7, and then length will be end minus, all right, 7 plus 1, 8, 8 minus 5. Okay. Okay, 5 mod 3 is equals to 2, so it returns a start of 2, that is 5 comma 7. Now what? Length is equals to, and for 7 plus 1, 8, 8 minus 5, that is 3, and 3 mod 3 is equals to 0. Now it return 6, 7. Okay. Hmm. Length is equals to 8 minus 6, that is 2. What's happening? I have no idea how to even tackle this. He wrote something, he cooked something. Function of. So you are just brute forcing it. So my thought process is correct. Like the modulus value doesn't matter how large the input is. You have only 0 case, 1 case, and 2 case, but cannot be correct all the times as well, because if let's say this 1 plus thing is called more than once, then your answer, would be clumsy. It would be more than one, but it is these two branches here are not allowing it to call for more than once, if you understood what I'm trying to say. So the maximum value would be either 0 or 1, but you need to prove that answer by yourself. Okay. Let's do 2, 2, which gives you a 0 case, 2, 3, 2, 4, 2, 5, and let's see how the behavior is, right? So the length is going to be 2 plus 1, 3 minus start. that is 1, and in this case the length is going to be 4 minus 2, that is 2, and here the length is going to be 3, here the length is going to be 4. Right, 5 plus 1, 6 minus 2, that is 4. And this is the base case, and length mod 3 is equals to 0. Nope. Right, here the length mod 3 is equals to 1. It is going to be returning 1 plus start command minus 1, that is 2 comma 2. And now the length is going to be like how much again? Right, all right, it is going to be 0 now. And now the length is less than 1. Now it returns 0, so it returns 0, so answer is 1 here. And here the length is 2, so the else case is going to be run function of start plus 2, that is 4 comma 3 is going to run here. And now the length value is how much? Right, and plus 1 minus 10, that is going to be 0. Right, if the length is 0, it is going to return 0. Cool, here it is 0. So now, as of now, we got 1 comma 0 as answers, and here the length is 3, 3 mod 3 is 0, and it is going to be return 3 comma 4 function. Right, you have seen this, and 3 comma 4. Now length is going to be, right, 4 5 minus 3, that is 2, and for length 2 it is going to return function of start plus 2, 5 comma 4, and 5 comma 4 is like, it is going to be 0, it is going to return 0 as well. You got a 0 again, and if you do this right, you have done all 3 successive cases, right? Yes, you got good at tracking. Hmm. Yeah, I guess that is enough. You got a function with 2 integers. If I is less than j and I is equal to 0. Okay, let's start from the main function. I is equals to 9, j is equals to 10. Function of I comma j, that is going to be 9 comma 10. Is 9 smaller than 10? No. Wait, 9 is smaller than 10, my guy. Right. 9 is less than 10, that is true. And int I is equal to 0. This is a local declaration that you need to be aware of. And here, like, the scope of I changed, and now j, uh, j plus r is equals to 2 I plus plus. When does this loop even end in the first place? Wow, wow, that's a nice question actually. J now will be 12 because the scope of j is here, and I plus plus scope is this, so I will be 1 now. Okay, and now 1 is less than 10, so j is equals to 14, I is equals to 2. So this kind of runs for like 1 2 3 4 5 6 7 8 9, and all right, you are supposed to see which value are you tracking. When I is 0 here, the j value became like 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. So j value becomes 30. Mm. Now what is the I value? It is 9 is less than 30. True infinite loop. No idea. Okay, I came until this stage. Dude, you did not understand question properly. So this is the scope one to open one to right. It is you don't even need to like do anything. Whatever the loop does, it does not affect I. Okay, you have like gave up in the midway and did not track the question like the source code properly. That's why I made some error. Okay. Struct node intel struct node next int get lister struct node head if e1 return 1 return e2 consider the following snippet in code language that computes the number of nodes in a non-empty single linked list pointed to the pointer variable head, which are the following options give the character replacement for the expression e1 and the expression e2. So you got expression e1 and you got expression e2 and okay, it contains alt something, right? And struct node next. Okay. Uh, Non-empty singly linked list. Number of nodes in a non-empty singly linked list pointer to a pointer variable head. Okay. Get list size. If head of next is equals to null, right? This is a head and it is a pointer. If head of next, this part null means there is only one node. Okay, that is true, and this count exists 1 plus get list size of head of next. B seems to be the valid option. Yep, that's our that's our Manasa ma'am for you who have taught us the linked list. Consider a hash table of size 11. That is it a gate previous question? Yeah, I guess so. Consider a hash table of size 11 that uses hash function h of x is equal to x plus 7 mod 11. Keys are inserted in the order. The collision resolution technique used is linear probing, which other table indicates table indices will remain empty after all insertions. Okay. Alright, 13 plus 7, that is 20. 20 mod 11 is 9. Alright, and 22 plus 7 is 29. 29 mod 11. 29 mod 11, that is 22 and 7. And right, 11 mod 7, that is 7 already. You just need to do this actually. And 29 plus 7, that is 36 mod 11. 11 3s are 33, that is 3 again. Okay, okay, where are you now? 29. 39 plus 7, that is 46 mod 11, that is 2. 44 plus 7, that is 51 mod 11. Right, 44 and then 7 again. So 9732 or what is linear programming? So you just put it in the next one or what? Let's do it. 978329 10. 2 is filled here, 10 is filled here. Alright, let us just check what is linear programming. Just in case. Open addressing collision resolution method where all elements are stored directly in a table and collision occurs sequentially for the next available slot, wrapping around to the start if necessary. Okay, makes sense. That is easy. I did not know what linear probing is. I mean, I know what linear probing is, but I forgot. The height of the binary tree is the number of edges in the longest path from the root to the height of the tree. That is the maximum possible height of a full binary tree with 23 nodes. Full binary tree. What is okay? You need to full versus complete binary tree. A full binary tree, okay, full in the sense it either has 0 or 2. Complete in the sense every level is possibly filled except possibly the last. So it goes something like this. Here is the root and here it is. And it goes like this, right? 1, 2, 2. Okay, makes sense. 2, something like this. So this will be 11 levels. The number of edges, you start from here because this is one edge already. 2 edges. Yep, 11 works out. I have understood at least what the question is dealing about. Let P be the set of all integers from 1 to 15. Consider an order of insertion of elements of P into a binary search tree that creates a complete binary tree. Which of the following elements can never be the third element? I don't know. Like, are these real gate questions or are these go questions? I mean, I'm not saying that they are easy, but I'm just asking. Okay, 1 to 15 integers. BST. Alright, creates a CBT complete binary tree. Can never be the third element that is inserted. Can never be third element. I have already did this. Like we kind of made a conclusion. Like if a complete binary tree is unique or not. If it is like supposed to be a complete binary tree, okay, you are not supposed to overthink it here. Let's say one is the element, and or maybe I have like okay. The question arises is: are you supposed to insert them in this level in this order only? No, right? You can insert them in any order. You can insert them in any order. So what do you do? Brother, add some explanation. I did not log into this or not. Here we are, right? Wait a minute, it is. Right. No, that is not at all a satisfactory answer. Let P be the set of all integers from 1 to 50. Order of insertion that creates a complete binary tree. It is not a binary heap where the order of insertion matters at every step as we fill it according to CPT prop at each step. The tree should be at CPT at the end after filling all 15 nodes. Okay. Yes, I have seen this. The same question that I have gotten actually. It is the same question that I have gotten. It is the same question as follows. Okay, that works out. It got added into the database. This is only one possibility. Okay. How can you construct like a complete binary tree out of this stuff? Yeah, that was great. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Right? These seven elements. It is going to be that median here 3 and here 3. 4 is going to be second median. Here 3 and here 3. 12 is going to be the third one. The third median and 4. You got 2. You got 1. You got 3. And you got 6. You got 5. You got 7. You got 10. You got 11. You got 9. You got 14. You got 13. You got 15. Need to be at least 4. All of these can be 8, 4, 12, 2, 6, 10, 14 can be third ones. Okay, that made a lot of sense. What a minute already. Thank you, thank you. What the Nobody even answered these things in the first place. Oh, why even bother? The following sequence corresponds to the pre-order traversal of the BST. The position. Okay, let's see. Pre-order is like root left, right, right. So 50 is going to be the root, and 25 is going to be the left, and 13. 40 30, अच्छा, 47, 75, okay, and 60. You will get it here, and 70. You will get it here, and 80. You will get it over there. 77. It is greater. So if you do this root and left, it's a root, root left and right. Okay, it is working out. The position of 60, the post order traverse 60 in post order. Post order is basically left, right, root, right, left, left. All right, let's post order this thing. Right, okay. Left and right, left, right, root. This one's done. The left is nope, the right is done, and then the root, and this is right, left, and then 25, and then the left is done. Now to the right, right. Now this one you are supposed to do left, 70, 60. This is the left is done, right, 77, 80, 75, 50. The position of 60 is 1, 2, 3, 4, 5, 6, 7 is going to be your position. Dun, 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 dun. When did we flag this thing? We flagged it someday. Okay. 44 minutes. Consider the following coordinate pattern C language that computes the number of nodes in a non-empty singular linked list pointed to variable head or struct node. Okay, we did this one. We pointed this one as well. Assuming a min heap n represents n is greater than 100 and n is odd, assuming one best indexing which of the following cannot be the index of the leaf node. Okay, that is a very good question. Brother asked a very good question. One base indexing n is greater than 100. Let's do 101. That is 50. You need to know array representation of min heap. I felt like I have asked this question already for like a For the first time, I have been solving this question, but yeah, we cannot do anything about it. Consider a mini containing n elements represented as an array. Consider a mini containing elements represented as an array. No. Okay. Parent node of an index is the lower bound of IN2. Okay, 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 okay. Now that sort of makes a lot of sense. 101 leaf stems from 101. Wait, this one. How much is this? 4, 2, 6, 6, 6, 12, 20, 24, 27, 639, 110, 127. Let's do this. 127 is CBT. 127 by 2 plus 1, right? 126, that is 64. Leave non-start from 60, 64. Leaves start from here. 126 by 2, that is 63. No, no, and 128 by 2, that is 64. Okay, 128. Okay. Nice. You just need to understand the basic formula to get this done correctly. How many questions have we done? It's been an hour already, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 questions in an hour. The speed is absolutely not enough. Get us your limits, man. Okay, okay. It is a game of scope. India is equals to 5. That is a block. Okay, into main. Into that. This is correct. I can say that. I feel like this is wrong. Here, what does this look like? This is scope. This is scope. Okay, now this thing is making shit up. No, that is. Look at that. Fuck off. It is dumb. It is 1 hour, people, and we'll go. Redeclaration. We cannot open to right. Let's see. Well, yep, yep. Congratulations. You have discovered the things that need to be discovered a long time ago. In our runtime environment, we have already did this. We did this one as well. Yeah, I guess it is enough for today, and let's sleep. Good night, everybody.